Okay, in this video, we're going to talk about section 2.2, dealing with definition of limits. And in this case, we're going to be talking about finding the limit of a function from a graph and also from a table. And also we're going to be looking at one-sided limits. That means taking the limit as x approaches some number from the left and from the right and find out where it's approaching. Okay, so here when we compute tangent lines and instantaneous velocities, those are just two of the many important calculus problems that rely on limits. Okay, now we'll talk about tangent lines and instantaneous velocities in chapter 3. So for now, we'll begin with a preliminary definition of a limit of a function. So here is that definition, and it is a preliminary definition of a limit of a function. Let's say we have the function f, and it's defined for all x near a, except possibly at a. So if f of x is arbitrarily close to some value L, as close to L as we like it for all x sufficiently close, but not equal to a, we write this: the limit as x approaches a of f of x equaling to some L. Okay, that's how we say it. The limit of f of x as x approaches a equals L. Okay, and also we can say that the limit as x approaches a of f of x equals L. We say that informally if f of x gets closer and closer to L as x gets closer and closer to a from both sides of a. That's from the left of a and from the right of a. And we're going to talk about one-sided limits a little bit later in this video. All right, so the value of x, the value of the limit as x approaches a of f of x, if it exists, depends upon the values of f near a, but it does not depend upon the value of f of a. In some cases, the limit as x approaches a of f of x equals f of a. And in other instances, the limit as x approaches a of f of x and f of a differ, or f of a may not even be defined. Okay, so now in this first example, we're going to find a limit from a graph. Okay, so here's a graph of y equals h of x. And from that, we're going to use it to find the following values if they exist. Okay, so in this case, so let's start up with part A. Let's say I want to find what h of 4 is. In other words, I want to find out what is the value of this function when h is equal to 4. So here's 4 on the x-axis. And if you look here, you do see a point. Oops, you do see a point right here. And that point is at the y value of 8. So that means h of 4 is equal to 8. Okay. Now part B. Let's say I want to find the limit as x approaches 4 of this function h of x. As x approaches 4. Okay. So here's 4 right here. If we look to the left of 4, as we approach 4, going in this direction from the left, it's going to be approaching the number 6, which is the y value here. It's getting closer and closer to 6 as we let x approach 4 from the left, and also from the right as we approach 4 from the right, which is sort of anything bigger than 4, as we let it get closer and closer to 4 from the right side of 4, it's also approaching 6. which is your y value. So that means the limit as x approaches 4 of h of x is 6. Okay. Now, if you compare the answers that we got for A and B, they're different. They're different because h of 4 came out to be 8. But the limit as x approaches 4 of the function h of x is 6, because as you can see on both sides, this graph on both sides approaches 6, but it will never reach 6. Okay. That's what we mean by where the limit as x approaches some value a of f of x and f of a can be different. All right, now on to part C, h of 7. So here's 7, this is 6, that's got to be 7 right here. Notice that 7, there's an empty circle there. That means that the value of this function at x equals 7 does not exist. So h of 7, the value does not exist. So here's another example where the function f of a may not be defined. So here's undefined at x is equal to 7. So that value of that function h of x at 7 does not exist. Now part D, the limit as x approaches 7 of h of x. The limit as x approaches 7 of h of 7. In this case here, I'm going to use a different color. If I look to the left of 7, here's 7 right here. I'll label that 7 on the x-axis. If I come from the left of 7, it's approaching some value. It's getting closer and closer to this y value of 2. And the same holds true if I approach 7 from the right. It's getting closer and closer to 7, but it's never going, it's getting closer and closer to 2. But it will never get closer and closer. They'll never get to 2. So the limit as x approaches 7 of h of x in both directions is getting closer and closer to 2. But will it reach 2? The answer there is no. And part E, the limit as x approaches 8 of h of x. Well, at 8, here's 8 right here. Well, notice it's going to be the same as what h of 8 would be, because at 8, the y value associated with that would be 3. So the limit as x approaches 8 is 3. Okay, so part E is an example where the limit as x approaches some value of a of f of x does equal to f of a. And in this case, the limit as x approaches 8 of h of x is the same as h of 8, which is 3. Okay. All right, on the next page is example 2. In this case here, we want to use the graph of g in the figure to find the following values, if they exist. So here is what the graph of y equal g of x looks like. And we're going to use that to answer these questions, like in part A, g of 0. Well, let's find out what that is at x equals 0. And by looking at it, you can see there's a point on the y-axis when x is equal to 0, and it's at 3. So g of 0 must be equal to 3. Okay. Now part B is the limit as x approaches 0 of the function g of x. The limit as x approaches 0 of g of x. Okay, so in this case, here's 0. If we come from the left of 0, like in this direction here, is the value of that will be getting closer and closer to this number right here. It's getting closer and closer to 2 from the left. And from the right of 0, the value of y equal g of x gets closer and closer to 2 as well. So the limit as x approaches 0 of g of x equals 2. Now you can see again that the limit as x approaches 0 of g of x and g of 0 are not the same. Okay, now part C, g of 1. What would be the value of the function when x is equal to 1? Well, here's 1 right here. Okay, and guess what? It's this point right here. It's on the graph of y equal g of x. The y value associated to that would be 3. So g of 1 is 3. And then part D is a limit as x approaches 1 of g of x. The limit as x approaches 1 of g of x. Well, in this case here, here's 1 coming from the left of 1. It gets closer and closer to 3, to the y value of 3. And coming from the right of 1, g of x gets closer, the value of g of x gets closer and closer to 3. So the limit as x approaches 1 of g of x is also going to be 3. And notice there that the limit as x approaches 1 of g of x has the same value as g of 1. All right, now let's look at example 3. Here I want to use the graph of f of x in the given figure to find the following values if they exist. So now in part A, I want to find out what f of 3 is going to be equal to. F of 3. Okay, so here's 3 on the x-axis. Notice that there is a point at x equals 3, and the corresponding y value for that will have to be the 5. So f of 3 equals 5. Now part B, let's take the limit as x approaches 3 of the function f of x. All right, so by looking at this graph, I'm going to see where it's coming, where it's approaching from the left and to the right. So here, if you look at f of x, to the left of 3, we're getting closer and closer to some value right here, which is in this case, -5, as you can see. That's between -4 and -6. So -5 means that the graph of f of x gets closer and closer to -5 as we let x approach 3 from the left. And also from the right of 3, the right of 3 means that the graph of f of x gets closer and closer to -5 as well. So the limit as x approaches 3 of f of x will be -5. And as you can see, they're not the same. F of 3 and the limit as x approaches 3 of the function f of x are not the same. Now part C, f of 0. Now at 0, at x is equal to 0, its y value is right here. and is at -6. Now for part D, let's say we want the limit as x approaches 0 of f of x. The limit as x approaches 0 of f of x. All right, in this case, let's say 0. To the left of 0 is over here. That's getting closer and closer to -6. And to the right of 0, f of x gets closer and closer to -6 as well. So the limit as x approaches 0 of f of x is -6. Let's look at one more of these from a graph. In this case here, we're going to use this graph of f in the figure to find the following values if they exist. So like in part A, let's find out what f of 3 is going to be equal to. F of 3. Well, at x equals 3, there is a point there, and it's on the x-axis. So the y value for that would have to be 0. So f of 3 is 0. Part B. Let's take the limit as x approaches 3 of the function f of x. So looking at this graph, as we let x approach 3 from the left side, it gets closer and closer to this y value of 2. And if we let x approach 3 from the right side of 3, the f of x value gets closer and closer to 2 as well. So the limit as x approaches 3 of the function f of x is 2. Now you can see that the limit as x approaches 3 of f of x is not going to be the same as f of 3. Now part C, the limit as x approaches, let's say 4 of f of x. Okay, so that's 3, this must be 4. Well, guess what? As we let x approach 4, it's going to be approaching this y value right here on the graph of y equal f of x, which is in this case would be 2. So the limit as x approaches 4 of f of x will be 2. Which is similar to saying f of 4, which is 2. And then part D is the limit as x approaches 5 of the function f of x. All right, so let's find 5. Here's 5 right here. And there's the point on that graph. And the corresponding y value for that will have to be 1. So the limit as x approaches 5 of f of x is the same as f of 5, which is 1. Okay. So that's how we find limits from a graph given to us. Now let's say we want to find limits from a table. In this case here, we can estimate limits using tabulated values of a function. Like in this example here, let's say we had f of x equal to x squared minus 4 divided by x plus 2. And in part A, we're going to calculate f of x for each value of x in the following table. And then part B is to make a conjecture about the value of the limit as x approaches -2 of x squared minus 4 divided by x plus 2. Okay, so here I'm continuing this on the next page of your handout. And here I'm going to be using my graphing calculator to do each one of these. So we're going to start off with these values that are given to us in the table. and use that function x squared minus 4 divided by x plus 2. Okay. And what I might do here is just go ahead and type this into the calculator, if they will let me. Okay, let me do y equal to, and then clear this out. The numerator and the denominator I'm gonna put in parentheses. So here, I'm gonna do left parentheses, press the xt theta n for the x, and then press x squared to square it, minus 4, close parentheses, then divide by left parentheses, x minus 4, xt theta for the x, plus 2. Okay. Now this is what I'm going to do here. I'm going to go to second and window. Now, under independent, I'm going to ask for the value. I'm going to let the calculator ask me what x values that I want to use, and it will give me what f of x is. So you want to make sure that the word ask is highlighted. If it's not, you want to use your you use the down arrow key, come down to independent, and then use your right arrow key to put the cursor over the word ask, and then hit enter. And then I'm gonna go to second graph to give me the table. And I got stuff here, so I need to, let me see if I can delete this stuff out, if it will let me. Okay. Here we go. Hit delete. All right. And now for my x values, I'm going to put in these numbers on the top row, starting with negative 1.9. And then hit Y1. Hit enter. And it'll give you what your y values are. So like for negative 1.9, the answer there will be negative 3.9. And then for negative 1.99, it'll be negative 3.99. And then for negative 1.999, that'd be negative 3.999. And then finally for negative 1.9999, I think this rounds up, but actually, if you were to do this manually, it would be negative 3.9999. Okay. Next would be for negative 2.1, 2.01, negative 2.01, and so on. So let's try negative 2.1, and see what's happening there. It'll be negative 4.1. And then negative 2.01, that'd be negative 4.01. And then for negative 2.001, it'd be negative 4.001. And then for negative 2.0001, it'll actually be this. But the idea here is this. If you were to look at this, if we approach negative 2 from the left of negative 2, you're going to see that these values are getting closer and closer and closer to negative 4. So the limit as x approaches negative 2, and that's from the left of negative 2. And by the way, that's how we write that. That's x squared minus 4 over x plus 2 is getting closer and closer to -4. And the other one is to the right of negative one. Well, one's to the left and the other one is to the right. And actually, this is to the right. The one on the bottom is from the left. So the limit as x approaches 2 from the right is approaching -4. Okay. Because our -2.1, -2.01, those are to the left of -2. And this one is to the right of -2. And that's going to give us, in both directions, -4. So the final answer, we can say here that the limit as x approaches 2 in general of x squared minus 4 divided by x plus 2 will be -4. X approaches -2. As you can see. Take a look at this example here where we got g of t is equal to t minus 81 divided by the square root of t minus 9. And let's say I want to make two tables, one showing the values of g for t equals to 80.9, 80.99, and 80.999, and one showing values of g for t equals 81.1, 81.01, and 81.001. And then we're going to make a conjecture about the value of the limit as t approaches 81 of t minus 81 divided by t, the square root of t minus 9. Okay, so in part A, we have the table already made out. So what we need to do there is just go ahead and find out what g of t is at each of those values. So here's what I'm going to do in my calculator. I'm going to clear this junk out. And I'm going to go to y equal to and clear out those equations that I have here. And I'm going to enter the t minus 81 in parentheses, but I'm going to use x. So it'll be left parentheses and then x minus 81, close parentheses. That'd be divided by, and then the denominator will be in parentheses. So it'll be left parentheses. Now the square root, I'm going to do second x squared for the square root. And I'm going to use x. And then I'm going to use my right arrow key to get out from underneath the radical, then minus 9, close parentheses. Now I'm going to do second and window because under independent, I want the calculator to ask me what x values that I want to use. So use the down arrow key, the right arrow key to put the cursor on top of the word ask, and then press enter because I want my independent variable, which are my x values, I'm going to enter them in myself instead of the calculator providing me those x values. Okay, now I'm going to go to second and graph. Okay, and in the first column for my x's, I'm going to enter these numbers in. So in this case here, for x equal 80.9, it will be, in this case, 17.994. And I think they want this to like 4 decimal places. However, I'll just have to do this. All right, so if t is 80.9, I do left parentheses 80.9 minus 81, close parentheses, and then divided by, and then left parentheses, second x squared for the square root of 80.9. Use my right arrow key to get out of it, minus 9. Close parentheses. So here, this would be 17.9944. And then for 80.99, I'm going to do this second and enter. And I'm going to change 80.99 by doing this second insert, and I'm going to put in another 9 there. So it'll be 80.99 minus 81. And then I'm going to do second insert again to put in another 9 there. I'm using second and delete to insert another value, number or digit. Then hit enter. So now we got 17.9994. And then for 80.999, this is where I'll do second and enter to pull this back up. Then I'm going to use my left arrow key. I'll do second and delete for the insert. I'll insert another 9 for 80.99. And then go here to underneath the radical, second, delete, insert another 9. That way I won't have to type all of that over. Use my right arrow key to go to the end and then press in enter. So here I got 17.9999. So from this, you can pretty much get an idea where G of T is approaching with these values, okay? And that's pretty much to the left of 81. This one is to the right of 81, since these numbers are bigger than 81. All right, so let's say 81.1. I'm gonna do second and enter. All right, let's change that first 9 to a 1 and then hit delete the other 9s. And do the same thing here. Change this to a 1 and hit delete for those other 9s. So this is what your screen should look like. And then hit enter. So here we got, I see what I made my mistake. That should be 81.1. And this also should be 81.1. Okay, so to 4 decimal places, this will be 18.005. This 5 will make the 5 in front a 6, 18.0056. And then for 81.01, let's do second enter. I'm gonna put the cursor on top of that 1 and do second and delete for the to insert a 0. I'll do the same thing here. Second, insert 0. Then hit enter. This will be 18.0006. And then finally for the 81.01, I do second, enter. Put the cursor on top of that first 0 and do second insert to insert another 0. Same thing here. Second, oops. Okay, second insert for another 0. Okay. So as you can see here, this will be 18.0001. So as you can see here on both sides of 81, G of T, the value G of T will be approaching 18. So here the limit as t approaches 81 on both sides of t minus 80 for the function t minus 81 over the square root of t minus 9. That will be equal to 18. Okay. All right, last we'll look at one-sided limits. So here the limit as x approaches a of f of x equals to L is referred to as a two-sided limit because f of x approaches L as x approaches a for the values of x less than a and for the values of x greater than a. For some functions, it makes sense to examine one-sided limits called right-sided and left-sided limits. So here's your definition of one-sided limits. For a right-side limit, suppose f is defined for all x near a, which with x greater than a. If x is arbitrarily close to L for all x sufficiently close to a with x greater than a, then we write it like this. The limit as x approaches a with a plus sign, that means x approaches a from the right of the function f of x equals L. And then for the left-sided limit, the limit as x approaches a from the left of f of x is equal to L. And we're supposing that f is defined for all x near a with x less than a. And if f of x is arbitrarily close to L for all x sufficiently close to a with x being less than a, then we'll write it like this. And we do say that the limit of f of x as x approaches a from the left equals L. And now the relationship between one-sided and two-sided limits. Here we're to assume f is defined for all x near a except possibly at a. Then the limit as x approaches a of f of x equals L if and only if the limit as x approaches a from the right of f of x is equal to L, and the limit as x approaches a from the left of the function f of x is equal to L. Okay, so let's look at some of these one-sided limits with these examples here. In example 7, we're going to use a graph to find the following limits and function values. So in this case here, starting with part A, the limit as x approaches 1 from the left of this function f of x. Let's see if we can answer these. And since this is a red, let me use a different color. So here's 1 right here. We're looking at what's happening to the left of 1. To the left of 1, the graph f of x is going to be approaching some value. And it's getting closer and closer to this value right here, 2. So the limit as x approaches 1 from the left of f of x will be equal to 2. Now in part B, the limit as x approaches 1 from the right. So here's to the right of positive 1. That value is getting closer and closer to 0. But it'll never get to 0. It's just getting closer and closer to 0. Now for the limit as x approaches 1 itself of f of x. Unfortunately, if you look at the left of 1, f of x is getting closer and closer to 2. But to the right of 1, it's getting closer and closer to 1. So Here, the limit on the left is approaching a value different from the limit for x as x approaches one from the right. So this limit does not exist. And by the way, for it to exist, the limit as x approaches one, the value for on the left, the limiting value on the left has to be the same as the limiting value on the right. Here on the left is getting closer to 2. On the right of 1 is getting closer to 0. Those are two different values. So the limit as x approaches 1 itself will not exist. Now, what about f of 1? Well, at x equals 1, here's the point, here's the value. When x is equal to 1 for that function, it's at 2. So f of 1 equals 2. Okay, and here's example 8. Say we want to use a graph of g of x in the figure to find the following values if they exist. If a limit does not exist, explain why. All right, let's start off with part A, g of 2. All right, g of 2. Let's find out what the function value is when g is equal to 2. Well, here's 2. At 2 is this point right here, and the corresponding y value for that when x is equal to 2 has to be the 4. So g of 2 is equal to 4. Okay, part B is a limit as x approaches 2 from the left. Okay. So if that's 2 from the left of 2, which is this right here, g of x is getting closer and closer to this value right here. The y value there is 2. So the limit as x approaches 2 from the left of g of x is going to be 2, based on that graph. Part C, the limit as x approaches 2 from the right of g of x. Okay, so here's 2 to the right of 2. We have to be over here somewhere. So if we look over here, what's happening to the right of 2? The value of g of x gets closer and closer to this point right here, which is, in this case, 4. So the limit as x approaches 2 from the right of the function g of x is equal to 4. So now, part D is the limit as x approaches 2 of g of x. All right, the limit on the left of 2 and the limit on the right of 2 must be approaching the same value. Otherwise, the limit does not exist at 2. Notice here, on the left, g of x is approaching 2, and on the right of 2, g of x is approaching 4. Here we got two different values here where the limit is approaching on both sides. So the limit does not exist as x approaches 2 of the function g of x. Okay, now part E. Let's find out what g of 3 is going to be, the value of the function when g is equal to 3. Well, here's 3. There is a point there. What will be the corresponding y value at 3? Has to be 2. So g of 3 would be equal to 2. Now, part F, the limit as x approaches 3 from the left of g of x. So let's find out what's going on to the left of 3. So to the left of 3, the value will be getting of g of x will be getting closer and closer to 4. So the limit as x approaches 3 from the left of the function g of x will be 4. That's part F. Now part G is a limit as x approaches 3 from the right of g of x. So to the right of 3, that's this right here, g of x is getting closer and closer to this point right here. It's getting closer and closer to 2. So here, the limit as x approaches 3 from the right of the function g of x will be 2. And then h, g of 4. What would be the value of that function when g is equal to 4? So here's 4. That means the point will land right here. And the y value that corresponds to that when g is equal to 4 will have to be 3. So g of 4 is equal to 3. And then finally, part I, the limit as x approaches 4 of g of x. Well, if we go to the left of 4, you'll see that the graph of g of x, the value of g of x gets closer and closer to 3. And if we go to the right of that, it's getting closer and closer to 4 as well. So the limit, as we let x approach the value on the left, is the same as the limit as we let x approach a value on the right. In this case, it's going to be 4. So g of x, the limit as x approaches 4 of the function g of x will be 4. And by the way, that's the same as saying g of x. So g of 4 has to be 4. Well, I'm sorry, it should be 3. Because at 4, it's going to be 3. Because to the left is getting closer to 3, to the right is getting closer to 3. So they're both approaching the same value on the left and on the right. Okay. So that will conclude this video on section 2.2, dealing with the definition of limits. Feel free to email me or contact me if you have any questions about anything presented in this video or in the homework on my math class.